loop optimization in compiler design in the part of code optimization. The code optimization can be significantly done in loops of the program. Spec- Specifically, inner loops is a place where program spends large amount of time. Hence, if number of instructions are less in inner loop, then the runtime of the program will get get decreased to a large extent. Hence, loop optimization is a technique in which code optimization performed on inner loops. The loop optimization is carried out by the following methods, or we can say the techniques can be performed for the inner loop. One is code optimization, induction variable and strength reduction. Third, loop invariant method. Four, loop unrolling. Five, loop fusion. Let us discuss these methods with the help of examples. Code motion. First one is code motion. Code motion is a technique which moves the code outside the loop. Hence, is the name if there is a some expressions lies some expressions in the loop whose results remains unchanged even after executing the loop for several times. Then such an expression should be placed just before the loop, that is outside the loop. Hence, before the loop means at the entry of the loop. For example, here we have the while loop in that I less than equal to max minus 1, curly braces open, sum equal to sum of AI close the braces. The above code can be, or this code can be optimized by removing the computation of max minus 1. Here we're going to be removing the max minus 1 outside the loop. From this, we're going to be taking out and writing here. Hence, the code optimization can be after writing, removing the max minus 1. The code will be like that n equal to max minus 1. We're bringing the max minus 1 outside the inner loop. So that the finally we're going to get the code like that n equal to max minus 1 while I less than equal to n braces sum equal to sum of a of sum equal to sum plus ai. This is the code motion. Next we are having the induction variables and reduction in strength. A variable x is called it as induction variable of loop L if the value of variable gets changed every time. Here we're going to be changing the variable value every time. It is either decrement or increment by some constant. Here we're going to be decreasing the or increasing the variable value in the induction variable. Here we have the example block 1. In the block 1 we are having the I equal to I plus 1, temporary T1 equal to 4 into J, T2 equal to A of T1. If T2 is less than or equal to 10, go to B1. In this code, value of I and T1 are locked states. Here I and T1 are locked states. That is, when variable of I gets incremented by 1, then only T1 gets incremented by 4. Hence, I and T4 are the induction variables here. Okay. When there are two or more induction variables in a loop, it may be possible to get rid of all by one. Sorry, all but one. Okay. When there are two or more induction variables in a loop, it may be possible to get rid of all but one. Coming to the reduction in strength. The strength of the certain operation is higher than the others. That is star or multiplication, we can say that. multiplication is higher than the plus. So that in the place of star, we are going to be replacing the plus. So that the strength, re- uh, the strength reduction technique, the higher strength operation can be replaced with the lower strength operations. Here we can see the example. Here we have the for loop I equal to 1, comma I less than or equal to 50, I plus plus. Open braces count equal to I into 7. So count 1, 1 into 7, next incrementing 2 up to 50. It is going to be loop is going to be running. Here we get the value of count as 7, 14, 21 up to 50. The code can be replaced by using the strength reduction as follows. That is, we are going to be replacing the star with plus. Let us see how we are going to be replacing. Here we write the temp equal to 7. So for loop as it is, in the count in the loop, the count equal to temp. Then temp equal to temp plus 7. Here instead of we are writing that I into 7, we are writing that count equal to temp, temp equal to temp plus 7. The replacement of multiplication by addition will spend up to the object code. Thus, the strength of operation is reduced without changing the meaning of the above code. That is, here the code will not be changed. The meaning of the code will not be changed by replacing with the plus. Like that, we have to write the or we have to reduce the strength. The strength reduction is not applied to the floating values expression because such such a use may yield different results. So it will be changes the results so that we are not going to be applying for the floating values. The reduction in strength. Next, we are having the loop invariant method. In loop invariant method operation technique, the computation inside the loop is avoided and thereby the computation overhead on compiler is avoided. Clear? What we are saying that the computation inside the loop is avoided and thereby the computation overhead on the compiler is avoided. That is, for example, we are considering this. Here we wrote the example for loop I equal to 0 to 10 do begin k equal to I plus a by b. Here we have the reading the a value and b value and performing the operation and writing the some statements end. This can be written as that means we are going to be removing this from the loop outside so that the code will be like this t equal to a by b for I equal to 0 to 10 do begin k equal to I plus t. So directly we are going to substitute in the performing the operation a by b value and storing in t so that I plus t here we are going to directly we are going to take the t value. That is the avoiding of loop inside the loop. That is we are going to be simplifying that. Next we are having the loop unrolling. In this method, the number of jumps and the test can be reduced by writing the code two times. Just simply we're going to be writing the code two times to avoid the jumping and the test. Let us see how we are going to writing. Int I equal to 1 while I less than or equal to 100 in the loop in the braces, curly braces, a of I equal to b of I. That is array of I, a of array of I and b of array of I. I increment. We are going to be incrementing the I value. This can be written as how we are going to write in that same code. Whatever we have the code here is going to be repeating twice. So that it is saying that unrolling. So you are going to be incrementing the code. Instead of two times, it is going to be running only the single time. At last one is the loop fusion. In loop fusion method, several loops are merged to one loop. So we are going to be merging the several function loops into the single loop. For example, we are having that for I equal to 1 to n do, for j equal to 1 to m do, a of I comma j equal to 10. This can be written as This can be written as for loop I equal to 1 to n into m. Do a of I equal to 10. Clear? Here we are writing the inner loop. Instead of that, we are going to write in that n into m. Instead of two for loops, we are writing the only single for loop, and we are going to be multiplying the n into m. Here we are going to get in that. Here is a small wrong. Here we are going to get only the I here. There is no j. We remove that j so that we are writing that a of I equal to 10. This is about the loop optimization in the inner loop programming. I hope that you understood the concept of loop optimization. Thank you.